Okay, welcome to lesson 5.5, Properties of Linear Relationships. So by the end of our lesson, we should be able to determine a linear relation given an equation, table of values, or a graph. So first we're going to use the function machine to fill out the table based on the equation y equals 3x minus 1. So remember, in a function machine, our input in this case would be the x value. We're going to take whatever we choose to be x, we're going to multiply that number by 3, and then we're going to subtract 1. What we get as our answer will be the y value. So we're going to fill in this chart using the input-output machine. So if I input negative 3, 3 times negative 3 is negative 9, minus 1 is negative 10. So my point x is negative 3, y is negative 10. If I input negative 2, well, we get negative 6 minus 1 is negative 7. So my point, negative 2, negative 7. If I input negative 1, negative 3 minus 1 is negative 4. So negative 1, negative 4. If I input 0, 0 minus 1 is negative 1. So 0, negative 1. 1, 3 minus 1 is 2. So 1, 2. 6 minus 1 is 5. So 2, 5. 9 minus 1 is 8. 4 here, 3 times 4 is 12, minus 1 is 11. Excuse me. And then the last one, 3 times 5, 15, minus 1 is 14. So 5, 14. Okay, so we have our table of values here. Next, we want to graph this. Okay, so we're going to use I'm just going to assume here that, actually I'm going to spread out my x, and this is my y. So for x, I'm going to spread it out a little bit. I'm going to call this 1, 2, 3, 4, 5, and then this is going to be negative 1, negative 2, negative 3, negative 4, and negative 5. On my y-axis, I'm going to have to count up by 2's. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And down here, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, and negative 20. Okay, so next we can plot our points. So when x is negative 3, y is negative 10. So right here. When x is negative 2, y is negative 7. Next we have negative 1, negative 4. Then 0 for the x, and y is negative 1. Then 1, 2, 2, 5, 3, 8, oh, whoops. Yep. Oh, whoops, I didn't do that on the 5. There we go. 2, 5, 3, 8. Move this up a little bit. And what do we got? 4, 11, and 5, 14. Okay, then we need to draw a nice line through this. Okay. Make sure to extend your line past your data. And then they also want us to find what the rate of change in the initial value are for this. So initial value, we could probably get pretty easily. We can just look at where our line crosses the y-axis. So that happens right here. So our initial value would be negative 1. And then our rate, well, again, we could draw a rate triangle anywhere on this. So I don't know, let's pick maybe these 2 points. So if we go here, we go from 1 to 3, so this is 2, and then here we go from 2 to 8, so that's 6. So my rise is 6 and my run is 2, so 6 over 2 is 3. Okay. How many ways are there to represent a linear relation? Well, we said that there are 4. What are they? We can do this by a graph, an equation, table of values, or a description. Okay, so moving on. So here we're going to take a look at table of values. We want to look at the relation to y equals 2x minus 3. We're going to make a table of values and calculate the first differences. So if we make a table of values here, again, input, output. So in this case, we have x is negative 2, so we want to do 2 times negative 2 minus 3. So 2 times negative 2 is negative 4, minus 3 is negative 7. Now you don't have to show this work each time. I'm going to do it for the first one, but not for the rest. We can just do it in our head. So 2 times negative 1 is negative 2 minus 3 is negative 5. This is 0 minus 3, so negative 3. 2 minus 3 is negative 1, and 4 minus 3 is 1. So to calculate first differences, you're always going to start from the bottom and work your way up. So I'm going to take these first two, I'm going to do 1, and it's a difference, so subtract negative 1. So this is like saying 1 plus 1, so this is 2. Now move up to your next set, negative 1 minus negative 3. Negative 1 plus 3 is 2. Negative 3 minus negative 5, also 2. And negative 5 minus negative 7 is also 2. So because if we look at our first differences, and because they're all the same, right, all the same, if that happens, we can say that this relationship is linear. They also want us to graph this relation. Okay, so to graph this, we can just plug in our points that we've created. So and I'm going to just, can we do this? Oh no, we're going to have to add in a scale on this one. So just count up by 1s, 2, 4, 6. And here we're going to have to count up by 2s. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, and negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Okay, so when x is negative, let's do a different color. When x is negative 2, y is negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. All right, so let's graph this line. There we go. And we should always label our equation with our line. Minus 3. Okay, so that one would be done. Oh, and classify as linear or nonlinear. Well, this one is linear. We can see it from the graph, right? It's a straight line, and the first differences also told us the same thing because they're the same. So we're going to try example number 3 now. So we have this new relation, y equals x squared over 2. So again, we want to plug this in. So we've got negative 4, make sure it's in brackets, over 2. So negative 4 squared is 16 over 2, which is 8. Okay. We can do the same thing for the next one, negative 2 squared over 2. So negative 2 squared is 4 over 2, which is 2. 0 squared over 2 is 0. 2 squared over 2, oops, is 2. And then 4 squared over 2 is 8. So now we want the same idea, calculate our first differences. So 8, work bottom up, 8 minus 2 is 6. 2 minus 0 is 2. 0 minus 2 is negative 2. And 2 minus 8 is negative 6. So because these are not all the same, so therefore this is non-linear. Next, they want us to graph this. So I'm going to use the same scale as my other one. So 2, 4, 6, -2, -4, -6, and then 2, 4, 6, 8, 10, 12. I don't have any negative y values, so I'm not even going to bother writing them in there, just to save some time. So when x is -4, y is 8. When x is -2, y is 2. When x is 0, y is 0. And then we've got 2, 2 here, and 4, 8. So this is a nonlinear one. This is one that you'll spend a lot of time with in grade 10. It's called a parabola. Because it's nonlinear, we can't draw a straight line, so we're just going to draw a curve to the best of our ability through all the points, and then label it as y equals x squared over 2. And then to classify as linear or nonlinear, well, we know it's nonlinear from our first differences, and we could definitely see that it was nonlinear from the graph. Okay. Oops. So next we want to consider the relation. First we want to rearrange for y. So I'm just going to rewrite what the question says, and then we want to rearrange for y. So I'm going to move everything away from the y. Remember to change its signs as we cross the equal sign, and then divide everything by -3. So we get y equals, simplify here, -6 over -3 is 2x, -12 over -3 is +4. Now we want to make a table of values and calculate first differences for that equation that we just rearranged. So here, again, 2 times -4 is -8, plus 4 is -4. 2 times -2 is -4, plus 4 is 0. 2 times 0 is 0, plus 4 is 4. 2 times 2 is 4, plus 4 is 8. 2 times 4 is 8, plus 4 is 12. So again, first differences, 12 minus 8 is 4. 8 minus 4 is 4. 4 minus 0 is 4. And 0 minus -4 is 4. They're all the same again, so this must be linear. So then we want to graph this. Y and x. 2, 4, 6, -2, -4, -6. 2, 4, 6, 8, 10, 12, -2, -4, -6, -8, -10, -12. Okay, so then let's graph this using the points that we have. So we've got -4 and -4 right here, -2 and 0 right there, 0 and 4, 2 and 8, and 4 and 12. Okay, and then let's draw our line. Label it y equals 2x plus 4. And classify as linear or nonlinear. This is linear. So hopefully we get the hang of that. Remember that a relation is considered a linear relation if any of the following is true. So if the graph is a straight line, table of values, if our first differences are all equal, or the equation, the base is x, and the exponent is 1. And we'll see a little bit more about how that works later. So we want to figure out if the following relations are linear or nonlinear. So first we have some graphs. So take a look at them. If it's a straight line, it's linear. If it's not, it's nonlinear. So here we have a big U, so this is nonlinear. Next, we have a straight line, so this must be linear. And the last one, even though there's kind of a straight part right here, it still curves, so it would still be nonlinear. All right, with table of values here, we're going to have to calculate first differences in our y's. So here, this one should be an easy one. It's always 2 minus 2, right? It's all 2 minus 2, and it always equals 0. So this one has to be linear. In this one, if we calculate our first differences, what is this? 9, 7, 5, 2. They're not the same, so it's nonlinear. Over here, what have we got? 3, 3, 3, and 3. So this one would be linear. They're all the same. Now let's look at our graphs, or our equations, I should say. So these ones are a little bit trickier. You have to be careful. So we're looking for the variable to just be x with an exponent of 1. So in this case, it is, right? We've got x as a numerator. It has base of x, exponent 1. This one is linear. The next one, we've got 4x squared. Because of that squared, this is nonlinear. This one, x is our exponent. It can't be the exponent. It has to be just a regular variable. So this one would also be nonlinear. In this one, this is just in standard form, but we still have x, right, with base. Let's do this. These are the wrong ones. So x is our variable. It has an exponent of 1. This one is linear. Next, y equals negative 6x. This one is also linear, right? We've got, we've got just a 6 with the exponent of 1. This one is tricky because if you look at it like this, you might assume it's linear, but make sure to solve for y to get y equals. And if we do, let's do this. If we wanted that, we'd have to divide both sides by x. So this would actually equal y equals 12 over x. And x can never be in the denominator. So this one would be nonlinear because x is in the denominator. It can only be in the numerator. And then these last two, y equals 5, well, this is just where y equals 1, 2, 3, 4, 5. It's actually a horizontal line. So this is linear. And then where x is 0, well, if x is 0, it's right here. So it could be, since it's x, it would have to be a vertical line. So this is still linear. And that's it for this lesson. So make sure you try your homework and ask me any questions if you